All right, let's take a deep dive into this idea of vertical asymptotes. Actually, let me get a pen ready here. Working pretty slow today. So remember that this concept, and we covered this in an earlier video when we were talking about the domain. We said for the domain, we cannot let the denominator equal 0, right? So we had to set up this inequality. And then we found that there were two values of x that would have produced a 0 in the denominator, 4 and -4. Okay. Now, we said at the time that these will be either vertical asymptotes or holes in the graph. But either way, we have to exclude them from the domain. And we showed two different ways to do that. So let's really zero in on what makes a vertical asymptote. There's a process to this. And when it comes to rational functions, it's always a good idea to factor the numerator and denominator first. So I don't want to make this a step-by-step process, but it kind of looks like that after a while. Okay, we're going to factor the numerator and the denominator. So on the top, we're going to have 2x and x. We're going to look for that magic combination. It happens to be +4 and -5. And on the bottom, we have the difference of squares, which factors into conjugates, right? So we end up with this. Now, when you see these, when you see this function graphed out like so, or factored out like so, you notice that there are common factors here, okay? And those are being multiplied, which is key here. So this is being multiplied by this, and this is being multiplied by this. There's no floating constants anywhere else in this numerator or denominator, so we know that these two factors can be canceled, right? And if we cancel these, okay, we're left with this simplified function. And it's just like simplifying a fraction. Simplifying functions is pretty much the exact same thing as simplifying fractions. Like 2/4 is equal to 1/2, right? They look different, but they represent the same values, okay? So after we factor this and after we cancel any common binomial factors that are on the top and the bottom, any 0 that remains is a vertical asymptote and should be expressed as a vertical line. So because we were able to cancel the x plus 4, the 0 that remains from here, right, is the 4, right? So we're going to say x equals 4 is a vertical asymptote. All right, and we would see that if we graphed this, right? So we still have to exclude it from the domain, right? When we're doing the domain, we cannot let x equal 4. But we're saying that this is a linear form, okay, at this point, because asymptotes are vertical lines, all right? And in terms of like what this looks like on the graph, let's take a look, okay? Plug this bad boy in. So we get 2x squared plus 3x minus 20 over x squared minus 16. So we zoom out here, right? We saw this in a previous video. This is where that line, and we can put this line in here. Oops, sorry, x equals 4. So this vertical line, x equals 4, we see that's where that asymptote is. And we could, again, zoom in real close and get all the way up here, okay? And we can see that as x approaches this value of 4, the y values are getting fast. Like take a look at just this point here where it's 4.062 and the y coordinate is 50.387, right? If we move to the left, 1/1000th, right? So it went from 0.062 to 0.061. The graph jumped up nearly 1 full unit. So we're moving 1/1000th of a unit closer to the line to the left, and the line is jumping up 1 full unit. Okay, so that's that steep action occurring as we get close to this vertical asymptote, all right, and what we call asymptotic behavior. Okay, vertical asymptotes are never going to get crossed. And when you see this, I kind of call it the invisible fence. Like if you've ever seen a dog in a yard that has an invisible fence, like it'll charge right at it, but it knows that if it gets too close, it's going to get shocked. So then it just starts running along the perimeter of the fence without actually crossing it. Same concept here, okay? And if you want to talk about like why this asymptotic behavior occurs. We're going to look at a different video here in a second. The one thing I want you to take away from this is, again, is this a step-by-step procedure? I suppose it is. You want to factor the numerator and denominator, and you want to do this anyway, because remember, everything that we did, if you look back at all of these problems that we were doing, we wanted to know what the zeros of the numerator were to find the x-intercepts. Okay, we wanted to factor this to help us find the domain. So factoring the numerator helps us find the x-intercepts. Factoring the denominator helps us find the domain. So we want to do these things anyway. Okay, so you might as well just factor right off the bat. Okay, the one thing that you'll want to keep in mind here, okay, worth noting, find the domain first, because you will, in some instances, be able to cancel these. So don't use the simplified function to find the domain, because if you cancel this out, you're going to be like, oh, well, I guess x can equal -4. I can put a -4 here and put a -4 here. Okay, we'll talk about what that means in a minute, but you have to use the factored form, not the simplified form, but the factored form to find the domain. Okay, so find the domain first before you cancel. Okay, before canceling common factors. Worth noting. All right. We're going to talk about asymptotic behavior in another video, and we're going to talk about what this means in another video as well.